So last time we talked about pricing bonds, and we briefly mentioned arbitrage methods, but we're gonna be more explicit about that now. So let's imagine that there are three different traded securities in the marketplace. So there is a 1 year zero coupon bond. It's a treasury bond that is finished paying, and so for $950 you can get a payment of $1,000 in 1 year. There's also a 2-year bond. For $950 you can get $100 and then $1,000. And then there's a 2-year strip. So treasury strips are they're securities that are created when someone who buys a treasury bond, right, a long maturity, many payments bond, takes it to the treasury and asks them to strip off the interest. So what they do is they create a security for each and every payment for the whole bond, and that way you just have one certificate for one payment, and that's it. So it'll say in 2047 I receive $65 from the federal government, or however much, and then those certificates trade just like the bonds trade. And so we have this, right? All of these securities are trading, and so an arbitrage argument works like the following. We would say, okay, right, the 1 year bond pays us money in year 1, and the 2-year strip pays us money in year 2. And so maybe we can turn a portfolio of 1-year bonds and 2-year strips into something that has the exact same cash flows as the 2-year bond. So if you look at that carefully, you can kind of see how it works. So we would say, well, let me buy 1/10 of the 1-year bond. So $95 to get $100. And so if we pay $95 to get $100, that would be the same cash flow as year 1 of the 2-year bond. So $95 plus $800, and if we buy 10 of the 2-year strips, we would get $800 for $1,000. So our total bill, or you think about the shopping list, we're getting 1/10 of a 1 year and 10 of a 2 year. So technically, if we were to actually trade this strategy in the marketplace, we would need to buy 1 year bond and 100 2-year strips, and that would create 10 2-year bonds. But since we can just do that, it doesn't really matter, and it's fine to work in fractions. So 1/10 of 1 year and 10 2 years is $95 plus $800. So that's $895. So you can already see what's happening here. For $895, I can make something that is worth $950. Right? Those 2-year bonds are selling for $950. And what happens then is you say, okay, I take my $895 and I pay $895, and then I borrow a 2-year bond and sell it short for $950. So now I have $55 in my pocket. And then let's think through what the cash flows are. So in a year, I get $100 from my 1/10 of a 1-year bond, and I have to pay $100 to whoever I borrowed my 2-year bond, and that cancels. And then in 2 years, I get $1,000 from my 2-year strips, and I have to pay $1,000 to the person I borrowed the 2-year bond from, and that cancels too. So you end up having no cash flows at all. Total cash flows are 0 everywhere. But I got $55. So basically, somebody paid me $55 for the promise to do exactly nothing in the future. Obviously, then we would do that a lot, over and over and over again. And what would happen is the price of the 2-year bonds would fall because we're borrowing and selling so many of them, and then the price of the 1 year and the 2-year strip would rise because we're buying so many of them. So we'd be putting sell pressure on the 2-year and buy pressure on the 1-year and the 2-year strip. So this is an arbitrage transaction. They do exist in real life, although they're increasingly hard to find thanks to computer algorithms searching for them. But they're how prices get adjusted to reflect reality. If there's logical inconsistency in the market, then arbitrageurs who are smart and want to make profits should be able to come in and make arbitrage profits on trading these strategies. And so this is the principal argument for people in who ascribe to the market as a rational actor, that the market in aggregate is rational and that it has efficient prices. That is, the prices that are in the market, the traded prices of things, should be reasonably accurate because the underlying securities are subject to arbitrage transactions. And naturally, right, if it costs $30 to trade a bond, then we'd spend $30 to trade the one and $30 to trade the other, and then $30 to sell the other one, and it would cost us $90 to do this, and then this wouldn't work, right? So if trading costs are too high, your arbitrage won't work. But if trading costs are a penny or 10 cents, then no, you're still pocketing $55, so it's just fine. So we talk about this concept of equilibrium because we would say there would be over demand for the 1-year bond and the 2-year strip, and then negative demand, right, sell demand for the 2-year bond. And that would continue until enough transactions happen to make them line up. And so anytime we have a lining up thing that happens, that concept we think about as equilibrium. It's the same kind of equilibrium you have, if you remember, in your high school econ class where you would do a supply and demand, where the bigger the price, the more producers want to supply, and the bigger the price, the less consumers want to demand. And so there's a point where those two curves cross, and the amount of supply is equal to the amount of demand. Okay, so let's suppose we want to replicate a 3-year bond using a 1-year bond and two strips, a 2-year strip and a 3-year strip. Right, so let's just go ahead and give that a shot. So I'm going to go ahead and copy this and paste it into Excel. We'll see if this is happy. Okay, it worked. All right, so I have my entity here. So we're going to go, and essentially we can go shopping. So we want quantity. Okay, how many 1-year bonds do I need? Well, I need $80. Each 1-year bond gives me $1,000. So I need, this many of them, just a fraction. Right, for the 2-year strip, I need 80. They provide me 80, so I just need 1. Right, that's easy. And this one, I need this, and it provides me 75, so I need a lot of those. Okay, so that's quantity. Price we already have, right? This is the price for these things. And so the total, then we could see a subtotal here, is just price times quantity. Just like if I buy 2 bananas and they're 10 cents each, they cost me 20 cents. That's no different than this. Right, we have 0.8 bananas, 1 apple, and 14.4 pineapples. Here's what they cost. We get a total bill for each item. Then take a sum of all these items and get the price of our replicating portfolio. Right, we're buying these. We're not buying this. Right, we didn't even use this number. We're buying these. And for $938, I can get this. Right, if I take the quantity times cash equals quantity times cash equals quantity times cash. All right, we get what matches, see? All right, we got the same cash flows as the other thing, only we paid $9.38 and everybody else is paying $9.50. So, of course, right, buy this, sell that, and we're good. So that is the same kind of argument we are using when we were doing bond pricing and we bought a perpetuity and sold a delayed perpetuity and then bought a lump sum payment. Those three things each have traded prices based on market interest rates, and so their portfolio combination that replicates the cash flow of the bond should have the same price. Okay, so the general process for doing these kind of, for thinking about these kind of questions is to start with the cash flow with the least flexibility. So if there's one that can only be supplied by one security, do that first, and then figure out what that means for the other years and try to get the leftovers with what you've got. Okay, so there's that. Now if we change the numbers around a bit, we could get a different transaction. So see here, the inflexible one is right here, so we have to do that first. And so we do this one first, and then we calculate a new cash flow, right? Because this is going to provide money now here. And so we would do year 3, then you do year 2, and then we would do year 1. So working our way backwards from 3 to 2 to 1, we can figure out how much we need of each and get a new total bill for the replicating portfolio, which is $977.98. Right, so what do we do when the replicating portfolio is more expensive than the bond? Well, naturally, you just buy the bond, and we pay $950, and then sell the replicating portfolio for $977. Okay, so this is an example that I did in class, and you could see what the students answered. 84% felt like there was no arbitrage possible. And so let's figure out what that would look like. So I'll go ahead and copy this. And this is what should happen normally in a well-functioning market. And we'll do the same argument as last time, right? So I'm going to do quantity divided by cash supplied. So I need 10 of those. Oh, excuse me, hold on, I got that backwards. So we need to do this one divided by this one, right? Because we're trying to replicate the 2-year bond here, right here. Okay, so I need 0.1 of, I need 0.1 of these. And how many of these do I need? I need this divided by that. Okay, so there's our quantity. And then price, we have 982. So if I do quantity times price, Control C, Control V, total it up, our replicating portfolio is $910, and the actual bond costs $910. And this is the usual case. So usually the portfolio should have the same price as the bond. I've actually done this in class with real quoted prices for Treasury securities, and the price ends up off by $1 or $2, and the reality is trading those bonds costs more than $1. So it's the relationship between the bonds absolutely fits within arbitrage bounds, at least every time that I checked, right? There was no free money to be had. Okay, so that's arbitrage arguments. Next up, we will talk about yield to maturity, but we'll do that in the next section.